So now that we've been through how to label each of the side lengths of our triangle and how to substitute those side lengths into the trig ratios, we're going to have a look at some questions that need us to find a side length or find an angle and how to do each of those. And like with Pythagoras, how there was two different cases, in trigonometry, as I've written here, there are three types of questions. So let's have a look at the first type. And I've written a list of steps here that we can follow for any kind of problem that wants us to or needs us to use these angles. So the first step, draw the triangle, that's been done. The second step, label the triangle with those side lengths. So we'll start with the easiest one, the hypotenuse. This time our reference angle is here. So our opposite is going to be the y, and our adjacent, the one left over, is 3.3. Now, remember in the last video how I said sometimes or most of the time we'll get a triangle where we don't have one of the side lengths labelled. And in this case, that is this hypotenuse side length. So I'm going to cross out that h because it's not relevant to this question. So I'm left with the O and the A. And if I have a look up here at my ratios, I need to get the ratio that needs an opposite and an adjacent. So sine opposite hypotenuse, it's got the hypotenuse in it, we can't use it, and that's the same with cosine. So I have to use tan. So I'm going to write down that tan formula. Tan of theta equals opposite over adjacent. And then I'm going to substitute in what I know. And in this case, I also have a value for my angle. So that angle is going to go in here in place of theta. So substitute in the values into the formula. That should say formula. So I've got tan of 86 degrees is equal to my opposite, which is y, over my adjacent, 3.3. Now comes the fun part, the algebra. So I want to get this y by itself. So I need to undo the operation of that y being divided by 3.3. So I'm going to multiply the opposite of divide on both sides by 3.3. And what that leaves me with is 3.3 multiplied by tan of 86 is equal to y. And then what I do is I go to my calculator, and if you're using the little green calculator, you'll see that there's a tan button. So you simply put in 3.3 multiplied by, press the tan button, and you'll see a little open bracket will show up. Pop in your 86, close the bracket, press enter. And it will give you the answer 47.19 if we're rounding to 2 decimal places. So y is equal to 47.19. So this is the first case. Don't worry too much about writing down the cases because I've summarised it on a page at the end. But that's the first case. And the good thing about the cases is that the algebra is going to be the same each time. You're just going to be multiplying, if it's this case, by a different number here to get to your unknown. Okay, so let's have a look at this one. Steps again, we've already drawn the triangle. We're going to label it this time. So, hypotenuse, my reference angle is here. So this is my opposite and this is my adjacent. Which one don't I need? I don't need this O because nothing's attached to it. So I'm looking at a formula or a ratio that has the adjacent and the hypotenuse in it. So it's not going to be sine, it's going to be cosine though. Cosine is equal to adjacent over hypotenuse. So let's write out that formula. So cosine of theta is equal to adjacent over hypotenuse. The next step, number 5, is to substitute the values into, I spelt it wrong again, into the formula. formula. So I've got cosine. I know my angle, so I'm going to change that to a 52, is equal to my adjacent, 16 over my hypotenuse S. Okay, this time we've got to do a bit of rearranging to get this S by itself. So the first thing I'm going to do, I'm going to go through all the algebra, but then I'm going to show you a little shortcut. So I'm going to multiply by the S on both sides, and then I'm left with S multiplied, let's change our colour. Then I'm left with S multiplied by cosine of 52 equals 16. And then what I'm going to do is divide by cosine of 52 on both sides. 2, and then they're going to cancel. And then I'm left with S equals 16 over cosine of 52, which I then put into my calculator, and I end up with S equals 16 divided by 16 divided by cosine of 52 comes out at, let's round to 2 decimal places again, 25.99, and in this case we've also got a unit that we need to check for. So this here was in centimetres, so we're going to make that centimetres too. Now the little trick I wanted to show you was if we circle, it's getting a little bit messy, but if I circle this original line and then I put another box around this line, you can see that all that's happened to get this S by itself is that I've switched this S with this cosine of 52. So if you want, I'll just draw it up here, if you substitute your values into your rule, and you've got cosine of 52 equals 16 over S, and you want to get directly to S being by itself, you can just switch these two around, and on your next line you'll have S equals 16 over cosine 52. So I don't mind if you do that. Okay, so this was the second case, and let's have a look at the third case. So our triangle's been drawn. We're going to label our triangle. Hypotenuse, opposite, adjacent. And I can see that my O is not relevant in this case, so I'm left with my A and my H, which is going to mean, let's have a look up here, don't want my O, don't want the one with O's in it, so I'm left with the cosine again. So I'm going to write down that cosine theta equals adjacent over hypotenuse. Substitute in my values. So in this case, the angle is my unknown, so I just leave that as theta. Adjacent 49 over 72. Now, we want to get this theta by itself. So the inverse operation, which is kind of like the opposite operation in this case, is multiply or taking the inverse cosine over to the other side. So it's cosine to the -1 equals 49 over 72. And that gets rid of the cosine from this side. Now when we go to put this in our calculator, I'm working off one of our little green calculators. We need to find the cosine to the -1 or the inverse cosine button. So to do that on the little green calculator, you need to press the second button and then the cosine button. And then what we're going to do is pop in that ratio, 49 over 72 equals 47 point, let's round to 2 decimal places again, 11, and we're working in degrees this time. So we've been through the 3 cases. Here's the working out for all of those cases, and I've popped them on kind of a summary screen that would be really good to write down in your book. So we've got type 1 is when we've got an unknown side length as our numerator. So that means when I substitute my values in, the unknown is at the top bit of the fraction. And in that case, you're always going to follow the algebraic step of multiplying whatever your numerator is to both sides to get that value by itself. The second type is the unknown side length as the denominator. So the ratios can change, but we're just looking at where our unknown is located. So in this case, that unknown is on the bottom half of the fraction. And remember, we learnt that little trick where we can switch them around. So you can skip that middle step if you want and just go directly to here from here, where we've just switched these two around. And the third type is where we have to use our inverse trigonometric ratios. So that means that little button on our calculator. It also means doing that for each ratio. So if you had sine here, if you needed to use sine, you would then have inverse sine here. If you needed to use tan, you would have inverse tan here. But always, always, always make sure you follow these steps each time and you're identifying which type you need to use, and follow the algebra along when you identify each type, and you shouldn't really make too much of a mistake.